Hello everyone. I am very happy to study the aircraft construction course with you. I am Zhang Qiyuan. Let's explore the structure of the fuselage together. The contents of this issue include pressurized area and non-pressurized area, form of fuselage structure, main frame components of the fuselage, and central fuselage section. Part 1, pressurized area and non-pressurized area. Modern civil aviation airliners have a very important system, an air conditioning system. It not only regulates the temperature, but more importantly, provides pressurization to specific areas on the aircraft. These pressurized areas include the cabin, where our passengers are located, the cockpit, the cargo compartment, where baggage cargo is stored, and the electronic equipment compartment, where key electronic equipment is stored. So what places don't need pressurization? Except for the pressurized area mentioned above, other parts of the fuselage belong to the non-pressurized area. For example, the radome at the front end of the nose, the tail part, tail of the aircraft, the nose landing gear compartment, the main landing gear compartment, and the air conditioning compartment, where the air conditioning equipment is located. The shaded area in the figure is a non-pressurized area, and the unshaded area is a pressurized area. Part 2, form of fuselage structure. Fuselage, as the main torso of the aircraft, its structural design is crucial. At present, there are two main basic structural forms, monocoque fuselage structure and semi-monocoque fuselage structure. Monocoque fuselage structure. The fuselage provides space for passengers, cargo, and equipment, and consists of many sections of structure, and each section of the fuselage will have a number, such as section 41. In a monocoque structure, engineers use internal frame assemblies and bulkheads to shape the fuselage. Most importantly, the outermost skin of the aircraft is riveted directly onto these frames, with no longitudinal stringer or beams. This design makes the skin itself take on the heavy responsibility of resisting the internal pressure of the cabin. Therefore, this skin must be made very strong so that the rigidity and shape of the entire fuselage can be kept unchanged. However, the monocoque structure faces a core challenge: how to make the skin strong enough to withstand enormous pressure while not being too heavy to increase the burden on the aircraft. This balance point of weight and strength is very critical. Semi-monocoque fuselage structure. In order to solve the weight problem of monocoque structures, a more commonly used solution is semi-monocoque structures. The design ideas of this structure are different. In a semi-hard shell structure, the task of bearing loads, including pressure, bending force, etc., is no longer mainly undertaken by the skin alone, but is shared by an internal skeleton network. This skeleton includes stringers or longer-ons, longitudinal main load-bearing member, frames or bulkheads, circular skeleton that maintains shape, stringers, small but large number of longitudinal stiffeners. The skin is installed on the internal frame and fixed to the reinforcing clamp plate by riveting or the like. This design brings a lot of flexibility and achieves excellent strength-to-weight ratio, that is higher strength with lighter weight. Therefore, the semi-monocoque structure can still maintain the integrity and safety of the structure when facing huge loads. This is a structural form commonly used by modern civil aviation airliners. Part 3. Main frame components of the fuselage. Regardless of the structure, the fuselage skeleton is composed of a series of key components. Let's meet these important bones and muscles. Frames. Imagine them like the ribs of the human body. The main function of the bulkhead is to maintain the shape of the aircraft, support the skin, and improve the stability of the fuselage. They also critically carry and distribute various structural stresses, such as shear and tension generated by flight, landing, pressurization, etc. When assembled, the bulkheads are usually arranged on the fuselage at even intervals. Pressure bulkheads. These are specially strengthened baffles located in key areas, such as the front fuselage tail, rear fuselage tail, wheel well area, and near the wing junction. They are designed to carry and distribute the different loads of the fuselage. Most importantly, the pressure-bearing bulkheads located at the forward end and tail of the fuselage, which form the boundary of the fuselage pressure compartment, are the core components that withstand the pressurization pressure inside the cabin. The front pressure-bearing bulkhead is shown in the picture. Stringers. These are longitudinal structural parts that fit snugly inside the fuselage skin. They run through the fuselage like long ribs. Since the fuselage needs to resist bending, shearing, twisting, and cabin pressure, the stringer is designed to transmit and carry these longitudinal loads. They are usually attached to skins and bulkheads and only interrupt at openings such as windows and doors. Engineers often use clips to connect strands and bulkheads, and the main purpose of these bulkheads is to transfer loads from the skin to the bulkhead and help reduce the compressive stress on the skin. Floor beams. These beams are positioned horizontally under the cabin floor near the skins on either side of the fuselage. See Figure 1-22. They are attached at both ends to the fuselage bulkhead. Floor beams undertake dual tasks. On the one hand, they help withstand the pressure load inside the cabin. On the other hand, they directly bear the weight of passengers and cargo transmitted from the upper seat rails. Keel beam. This is a key support component located on the center line of the bottom of the fuselage below the central wing box and connecting the two main wheel wells. See Figure 1-24. Imagine it is the spine of the fuselage. It usually consists of strong compression rims, shear webs with stiffness, strands, ribs, skins. Due to the existence of the keel beam, the structure of the wheel well area does not require skins and stringer systems to be able to open on the fuselage to facilitate the retraction of the main landing gear, and the vertical shear force of this part is bound by the keel beam. In addition, the keel beam will also bear various loads together with the fuselage skin and stringers outside the wheel well area. The skin constitutes the aerodynamic surface of the outermost layer of the aircraft. It is also an important structural component in itself. Under the grid support composed of stringers and bulkheads, the skin undergoes a large part of the flight load, stretching compression shear. The skins are essential to prevent local buckling of the structure and to maintain the integrity of the cross-sectional shape of the fuselage. The skin is generally a solid aluminum alloy thin plate, and a honeycomb sandwich structure is used in positions such as hatch and cover plate. What is seen in the figure is the skin of the honeycomb sandwich structure. Part 4, Center Fuselage Section. Finally, let's briefly look at this special part of the central fuselage section. The center fuselage section is the core area of the middle section of the fuselage, which connects the center wing box with the main landing gear. See Figure 1-25. There is a key point here. The skin on the upper surface of the central wing box and the pressure seal of the wing box extension above the main landing gear compartment together form the lower boundary of the cabin pressure. The front and rear boundaries of the cabin pressure are formed by a pressure-bearing partition, that is the aforementioned pressure-bearing partition located at the front of the central wing box and the rear of the main landing gear compartment. Under the central fuselage section below the bilge is a non-pressurized area. Thank you for studying. Now comes the exercise session. Students can press the pause button to think and answer. Let's start now. Have all the students answered correctly?